Hi, grade nines. Today we are going to look at reflections and lines of symmetry. So, what I want us to try and do here now is I want you to think about this. I want you to think about what would happen if we were to draw a line to each of the objects. And here's the thing that we want to do. We want to see how we can cut the objects into two mirror image halves. So for example, we want to draw it so that there's an equal amount of stuff on both sides of the line, and where a line is, it looks like a mirror could go, okay? So let me go to my line tool here. So we'll start off with the arrow in the top left-hand corner. Can we draw a line of symmetry? And in fact, we can. And that line of symmetry would look like that. That line of symmetry would cut that arrow in half. So that arrow has a line of symmetry. Now the question that we should ask ourselves is, does it have more than one line of symmetry? In other words, can I do that somewhere else on the arrow? And the answer to that question is no. The only line of symmetry that works is the one that we drew. Okay, cool. Then let's go on to the X. The X, can we draw a line of symmetry? Sure we can. That line of symmetry would be like right here. There's a line of symmetry. Can we draw another line of symmetry? There's a second line of symmetry. Could we draw a third line of symmetry? Right there. How about this? Could we draw a fourth line of symmetry? Right there. So that X has 4 lines of symmetry. The arrow only had 1, but the X has 4. Okay. Now, on the far right at the top, we have a trapezoid. Does the trapezoid have any lines of symmetry? So, the trapezoid would have 1 line of symmetry. And that line of symmetry would be a vertical line drawn like that. How about the rectangle in the bottom left? How many lines of symmetry would be there? Well, we get a vertical one right here, and we get a horizontal one right here. The vertical one's a little off, but you get the idea. So there'd be 2 lines of symmetry for a rectangle. The next thing we have is we have a pentagon. Can we draw a line of symmetry for that? There's 1 line of symmetry. Can we draw another one? Sure can. Is there any others? Yep. Any more? Sure. And is there any others? And there we go. So the pentagon has 5 lines of symmetry. 5 lines that you can draw through it to cut in half. So you really have to look at what the shape is, or what the image is, to see where the lines of symmetry go. And if you're drawing a line of symmetry, it always makes the most sense to draw it with a ruler, or anything that's straight. So it could be the side of a book, could be the side of a calculator, side of your phone, anything, as long as it draws a straight line. And we have one more shape to look at here, and that is a triangle. Is there any lines of symmetry for this triangle? And there would be one. right like that. So there's just a little exploration with drawing lines of symmetry through shapes, and we're going to use that to help us do some examples in today's lesson. So let's do a little bit of learning. A line of symmetry is also called a line of reflection. If a mirror is placed along one side of the shape, the reflection image and the original shape together form one larger shape. The line of reflection is a line of symmetry of this larger shape. So what that's saying is this. If we were to have only this drawn right here, and this line of symmetry, we would reflect the yellow highlighted part over the red line of symmetry, and that would give us this part. And together, the yellow and the green highlighted parts form a larger piece. Okay? So that's why lines of symmetry and lines of reflection are very closely related to one another. You can use a line of reflection to draw an additional piece, like we could do with the yellow and the green highlighted parts. And then together, when you have the yellow and the green that make together a bigger object, that same red line is now a line of symmetry through that object. Okay, next example. Identify the lines of symmetry in the tessellation. So we have a whole bunch, there's some isometric dot paper, and we have some objects drawn through it. And what we want to do is we want to try and see where would the lines of symmetry go. Okay, where are those lines of symmetry going to go? You have to be careful. You have to take a look at this and you have to say, okay, where would this go so that there's an equal amount of stuff on both sides of any line of symmetry that would exist. Okay? So, is there a line of symmetry here? Well, there is one for sure. And that one line of symmetry is going to go right here. That would be a line of symmetry that would cut that in exactly half. Now, is there any other lines of symmetry that work? Well, there's another line of symmetry because there's an equal amount of stuff above and below that horizontal line that we just drew. And you may say to me, well, could you draw any diagonal ones? Well, you can't because it would not give you an equal amount of stuff above and below. So for that reason, there's only two lines of reflection or symmetry rather in this tessellation. Okay? So now we're going to take a look at another example. And here what we're going to do is we're going to pretend that the red triangle is like our base triangle. And what we're going to ask ourselves is, can triangles A, B, C, and D be created by using a line of reflection? Can you reflect the red triangle in any line to give us triangles A, B, C, and D? Okay. So, right off the hop, what you might say is, if we take a look at triangle A could be produced by reflecting in that green line right there. That's going to give you triangle A. Okay? So we can write that up too. We can say that triangle A is a reflection through, it's a line that goes left to right, so that would be a horizontal line. Now the horizontal line is in a special position, and the special position that the horizontal line is it goes through 6. Every y value on that line is 6. So we would say that triangle A is a reflection through a horizontal line, and that line would be y equals 6. Okay? Now, triangle B is tricky, so we're going to skip triangle B for just a minute. Let's talk about triangle C. If we think about triangle C, the line I just drew, if the red triangle is reflected through that line, it'll reflect and give you exactly triangle C. So we can go ahead and write that up then. We can say that triangle C is a reflection. It is a horizontal line again, so we would say through a horizontal line. It's not at y equals 6 this time. This is between 2 and 4. So of course, between 2 and 4, you have 3. So it's y equals 3. So triangle C is a reflection through a horizontal line y equals 3. Okay? Now, we're going to look at triangle B. Triangle B can be produced, and it would be produced if we reflected the red triangle through the line that I just drew. This is not a horizontal line, it's not a vertical line either. We would call this a diagonal line. There are more technical terms, but we can just stick with diagonal line because it's easier to say and easier to think of. So if we reflect that red triangle through that diagonal line, it would give us triangle B. So triangle B is a reflection through a diagonal line. We don't have a way to say what's on the diagonal line other than saying what points it goes through. To see the points that it goes through, it'll start up here at 10 on the y-axis, and it'll end here at 10 on the x-axis. So we'll say then that triangle B is a reflection through a diagonal line that passes through ten on the y-axis and 10 on the x-axis. That's a mouthful, but it is a way to describe how we can reflect the red triangle and give us triangle B. Now, what we might want to do is we might want to turn our attention to triangle D. Can triangle D be created from a reflection of the red triangle? The problem is this. Because the triangle is only changing position horizontally, it means that there's going to have to be a vertical line. And what we can see is the red triangle points to the right. If we had a line that came down like this, and we reflected the red triangle through that line, then the resulting triangle would not point to the right, it would point to the left. So that's like a hint or an indication that we cannot make a line so that the red triangle can be reflected over that line to give us triangle D. Because the orientation or the position of triangle D is not consistent, or what it should be when the red triangle would be reflected in that line. So we need to say that, which doesn't really, we don't have to go into all that detail. We just say that triangle D cannot be shown as a reflection of the shaded or red triangle. Okay? So that's how we would talk about triangle B, or triangle D rather, is it just doesn't work because of that inconsistent orientation, how the triangle points. It's not what it should be. Okay? Okay. And with that, we have one more example. So here we go. So we'll zoom in here so we can see this nice and clearly. We have a quadrilateral. A quadrilateral, if you recall, is any four-sided object. A parallelogram, square, circle, rhombus, trapezoid, kite are all examples of specific quadrilaterals. We've got a quadrilateral drawn below. Also, when we draw a shape and the shape has corners or points, we put labels at those corners or points, and you can see we did that here. This is A, this is B, this is C, and this is D. We're going to be doing some reflections of this quadrilateral, and when we do that, we're going to also use that same kind of idea where we label the corners or points or vertices of these objects. So let's take a look at part A. Part A says, a line of symmetry is drawn through 5 on the y-axis. Draw the resulting shape and comment on the new shape. So the y-axis is the vertical axis, and if a line is drawn through the 5, what that means is we have to find 5, and of course 5 would be right here. And if we draw a line through 5, then we are going to reflect the quadrilateral over that line. And what do we get? So The new A is going to live right here. I'm going to call that A prime because it's not the original A, so we'll call it A prime. The new B is going to live right here. I'm going to call that B prime. The new C, because C lives on that line of reflection, it doesn't move. And the new D, the same thing happens there. It doesn't move because it also lives on the line. So if we draw the resulting quadrilateral, A, B, C, D, and then back to A, we get this. And this entire thing forms a new shape. So we drew quadrilateral ABCD after being reflected through that line. And now what's the new shape? Overall, what's this shape? Well, this shape has 5 sides. A 5-sided shape is known as a pentagon. So we would say that the new shape is a pentagon. And again, a pentagon is a 5-sided shape. Okay? All right. Now we'll go on to part B. So part B says, if a line of symmetry is drawn through 6 on the x-axis, draw the resulting shape and comment on the new shape. So where is the x-axis? Well, the x-axis is down here. 6 is right here. So we're going to be drawing a line through the number 6. And then we're going to reflect the pentagon over that line. So if we reflect the pentagon over that line, the new A is going to be right here because it's 2 grid squares away from the line. The new D is going to be out here because it's 4 grid squares away from the line. So it's D prime. B and C live on the line so they don't change positions. So that's what we get when we draw the resulting shape, when we reflect it over that line of reflection. And the overall shape becomes something that looks like this. And this, how many sides does this shape have? 1, 2, 3, 4. It's a quadrilateral, but what type of quadrilateral is it? It's a trapezoid. How do I know it's a trapezoid? A trapezoid is a quadrilateral where 2 of the sides are parallel. If you haven't talked about what parallel means, think of it this way. This side right here goes like this. This side right here goes like this. If we continue those lines forever and ever and ever and ever, left or right or both, those 2 lines are never going to cross. Those lines are going in the same direction, exactly. Because they're both flat horizontal lines, they're both in the same direction, which means that they're parallel. And if you have one pair of sides that are parallel, and that's it, then we say that that shape is a trapezoid. Okay? So that's what makes the resulting shape a trapezoid. And with that, we'll do the last part. The last part is part C. If a line of symmetry is drawn through the oblique line containing the points 0, 3, and 7, 10, draw the resulting shape and comment on the new shape. So, where is the point 0, 3? 0 corresponds to the x value, so 0 would be here, but then it says 3, so that's the y value. So that actually means that trying to move that there, but that's the y value right there. So this point right here represents the point 0, 3, because the x value is 0 and the y value is 3. Okay. Now, the other point it gives us is 7, 10. So, 7 on the y-axis is right here, x-axis, sorry, 7 on the x-axis is right here, 10 on the y-axis is right here, so we go to where those points meet up, and those points meet up right here. So this is 7, 10 right here, so we're going to draw a dot at 7, 10. And then we're going to draw a line connecting those points. And what we see is that it goes along exactly this part of the shape. So what we're going to do is we're going to reflect the trapezoid over that line. So what happens when we do that? Well, what happens when we do that is C used to be 4 units to the right of the line. Well, now it's going to be 4 units above the line. So that's the new C, that's C prime. B used to be 2 units to the right, now it's going to be 2 units above the line. So now this is going to be our B prime right here. A and D live on that line of reflection. So now we can draw the resulting shape. We get that. And if we take a look at the combined shape, one side, 2 sides, 3 sides, 4 sides, 5 sides, and 6 sides. So it's a 6-sided object. A 6-sided object is a hexagon, and this is in the shape of the letter L. So all we're going to say, it doesn't have to be fancy, we're just going to say that the resulting shape is an L-shaped hexagon. Okay? When you go ahead and do questions like this, it is important that you draw your lines of reflection. So just as a reminder, the line of reflection here is this line right here. And please do so with a ruler or something that resembles a ruler in terms of being straight. And also, please remember to include your labels of your new corners or points or vertices. So we have B prime and C prime. Make sure to include those on your diagram, because giving a complete diagram shows complete understanding of these questions. Now, to get some practice to make sure that you know what's going on, you can work on pages 357 to 359 in your textbook, try questions 3 to 10, and make sure to ask for help if you run into some problems.